Okay, let's talk about Euler's method. We're going to use this. It's a way of approximating values of a function that you don't know, but you do know the form of the derivative of that function. So this is a differential equation because it involves the derivative as well as other values. Okay. So the way this works, we're starting at 1, 1, and we're going to go with a delta x of 0.1. So we're going to move forward through this process. And so the x values I'm going to use are going to start at 1, and then my next x value will be 1.1, and then 1.2, and then 1.3, 1.4, 1.5, and then I'll eventually get to the 1.6 that it was asking me to approximate. I know that my first y value is also 1. Now, what the derivative does is it tells me, basically, it says I'm standing at the point 1, 1. This is going to tell me at that point what direction I should be walking. Okay, where am I going to move from that point 1.1? If I calculate it, this first one, the dy dx, is going to be 1 over 1 minus 2 times 1. So 1 minus 2 is negative 1. So my dy dx is negative 1. Okay, so this is like I'm going to take a step in a straight line. Because of local linearity, I can go in a straight line and expect that I'm not going to be in exactly the right place, but I'm not going to be too far away as long as the steps that I take are not very big. Okay. I know that what's happening then is that my dy dx is being approximated by delta y over delta x, a change in y over change in x. I know that my delta x is going to be fixed at 0.1. So this becomes this dy dx, this thing that I can calculate, which in this first one is a negative 1. So let me do it for this first one, and then we'll use that as a general pattern from there. Negative 1 is equal to delta y over 0.1. And so if I multiply both sides by 0.1, I get that delta y is equal to negative 0.1. So I'm going to put that in here to tell me how far I'm going to change my y. So my first delta y is negative 0.1, matches the size of my delta x, which is not surprising because my slope was negative 1. And so this says when you move x forward by 0.1, you should back y up by 0.1. So it's going to be 0.9 now. So there's the first place. And now I need to do another calculation to see what my dy dx is from this point. Because now I'm in a different place, it should change things. So this dy dx calculation is now going to be 1.1 divided by 0.9 minus 2 times 0.9. Okay, I'll get my calculator out and run through that. So 1.1 divided by 0.9 minus 2 times 0.9 gives me a negative 0.57 repeating. We want to keep a bunch of decimal places as I go along here. So how much is my change in y? Well, the way this worked out was my delta y was always going to equal whatever the dy dx was times 0.1. Okay, so if we multiply that by 0.1, then my change in y is negative 0.057. Making a mess out of things here. Negative 0.057 repeating, which is on my calculator screen right now. So let me see if I can get a better focus on things here. And my dy dx was x, which is, so I first of all have to figure out my y. So my y is going to be the 0.9 plus my delta y, which was that previous answer that I had in there. So I'm now at 0.8422. Try to keep at least 4 decimal places here as we go along. So my dy dx now, new calculation, x, which is 1.2, divided by the y value, which was the last answer that I had, minus 2 times the last answer that I had. Okay. Gives me a negative 0.2596. Hoping that that came out right. I'm nervous now because I didn't put times there, but I'm going to go with it. Negative 0.2596. Yeah, I feel good about that. The change in y then is going to be that number times 0.1, again using the formula that's over here, which puts me at a negative 0.02596. That's how much I have to change my y value for by, so I will add my old value of 0.8422. I'm going to throw another 2 on there. And now I'm at 0.81626. That on there. And now I'm ready to do a slope calculation again, which is going to be my x value, which is 1.3, divided by that previous answer minus 2 times that previous answer, and that is a negative 0.03987 times 0.1 puts me at things are getting in my way now. I'll try to do this over on this side. Negative 0.003987. That's the change in y. The y that I had to change was the 0.81626, which puts me now at 0.81227. And I'm ready to calculate a new dy dx. My 1.4 divided by the previous answer was the y minus 2 times the previous answer gives me a positive slope this time, 0.09901 times 0.1 is 0.009901. That's how much my y has to change. My y was that 0.81227, and my new y value is 0.82217. And so my new slope is the 1.5 divided by the previous answer minus 2 times the previous answer, which is 0.18009 times 0.1 is 0.018009. I'm going to change my y value, so plus 0.82217, and my new value is 0.840218. I'll go with that. And so approximate y when x is 1.6. This is my approximation for y. Gets very repetitive. You can see how a spreadsheet would help quite a bit with this, moving the formulas around in there. You can see the different columns that we're building every time. It wouldn't be hard to have it continue to do that for you. The advantage of a spreadsheet is we could go much further and we could be more accurate. We could go with a smaller delta x. I mean, we could run this out for a long way, but we figure with the size of steps that we're taking, we're probably getting away from we're losing some of our accuracy on the answer. Could get more accurate with a smaller delta x, but it would take a lot more steps to get there. If we went with a delta x of 0.01, we would have taken 10 times as many steps to get to the 1.6 from there. So, which is a pain by hand, but not bad with technology. All right, that's what Euler's method looks like.